So today I welcome you all to our tutorial on building a to-do list app using .NET MAUI, where we will explore the concepts of dependency and dependency injection and data binding. Now remember, if you have visited my last lecture on YouTube, that is now wherein this was mastering .NET MAUI, understanding the initialize component method. So I have kept this section 4, best practices and gotchas, in which I wanted to discuss basic data binding in a .NET MAUI app together with dependency injection, and I have kept it for an upcoming video, and that is this video where I am going to tell you everything in much more detail with the to-do list app, and we'll build it from scratch code by code and class by class and method by method. So here is our Visual Studio. So on to Visual Studio, and I've got recent project templates .NET MAUI app, and I will click next and give it the project name, say to-do list app, to represent what I am going to do, that it is going to be a to-do list app, and I'll put it on my default location, and solution name is the same, and keep it unchecked, and then click on next to create the project with .NET 8, which is the latest and long-term support. So create the project now. So the basic project is created, which I will show you, which I have already shown in my previous videos, but we'll change it to make it give a look of to-do list app, which is I will show you. So at the moment it is just a hello world application, and click me and click 2-3 times, which you are now familiar with. So we'll just stop the application. So we are going to end up building this to-do list application, where these are the tasks and these are slide switch, so you can start it on and off. By default it will be on the off position, and also you can add to do item, so you can create another task, say task 5 or anything, and that will be added. So this is a list view collection, alright, and this is a button, and these are the slider switches, and this is a label. Alright, so over to some very interesting times ahead. So in our to-do list app, we will use data binding to bind the UI elements such as the list view and button to our view model. So we will be using a view model, which will be soon coming into fruition. So let's start by creating a models folder for the to-do list class. So that will be the information that is needed to build a to-do list. So click on add, and I will add a new folder. So a models folder is added, to which I will add a class. To-do list class. Actually a bit of change here. Let us make it to do item. Let this be called a to do item with a public access modifier, public class to do item, and I can change to do list to do item, or I can keep it like that. So let's change it. It's a better idea to do list to do item, so that the class name also reflects the file name, to do item.cs. Okay, public class to do item. And now I will have my to do item class is complete. So it has got this ID and its basic title field and is completed field. So why this is completed field and how it will be used into a UI, which will be soon clear. It will give it a toggle switch. So for that I will be using this is completed property. Alright. So next is, to the project I will add a services folder. new folder and name it services. Add a new item. This will be an interface. iTodo service. So iTodo service.cs, that is a public interface. Okay, so this we'll have to fill this iTodo service. So public interface iTodo service, and we have these members. So namespace is TodoList App dot services and public interface iTodo service, which has got 3 members. Get to do item async, which returns a task of list of to do items, and add to do item async. Add this method to add a new to do item, and toggle to do item completion async. So this method is added to handle tap events on to do items. We'll soon know what is a tap event. Okay, so just save it. The next thing is to create a to do service class. So add a class, the to do service class, which uses iTodo service interface. So it is implementing iTodo service interface. So to do service, again public class to do service. So let's start writing this class to do service, which derives from iTodo service, or which implements rather iTodo service interface. Alright, so it is complaining because it does not implement all these members. Okay, so we'll soon implement. Don't worry about this red squiggly lines. So list of to do item, include this namespace. So we're using TodoList App dot models. We'll get rid of the squiggly line. So I'll create a private list of to do item and call this underscore to do items with an underscore. So, and in the public constructor, I will initialize this underscore to do items. So if you write anything, it will give you all the members. Okay, so if you forgot what are the members of this to do item class, so just write anything, it will give you all the members. So first is ID. Let's give it a hypothetical ID as 1. Title field is required, so title is say task 1, and give it a gap to make it nicer. Is completed. Yes, false. Okay, that's one member. Make it a bit indented. So now just copy it over. ID 2, make it task number 2 or task 2. is completed true. See, right, and then put a semicolon and then put another task, say id equals 3, task 3 is completed false, indented nicely. Alright, and then I have to implement the members. So what were the members? Here we have got get to do item async, get to do items, async, so you can write async task await, it's followed by await. So it's not allowing me to do the await keyword with the my code task dot from result to do items. So I will just get rid of this async, let it be non async operation. Return. I'll come back to writing it asynchronously, task dot from result and to do items. So what this does is it simultaneously, or it simulates fetching data asynchronously, that is, for example, from a database or a web service. Now to put it public async task, so if we put an async keyword here, so it has to follow an await keyword. Okay, let's write here await, let's see what happens. Okay, it's allowing us to return a which is awaited task dot from result, right? So what is this task dot from result? It creates a task of t result type that's completed successfully the specified result, and it is an async call, so it actually simulates the fetching of the data asynchronously from an API or a web service or a database. Alright, that was the purpose of putting it as an async and await type operation. Okay, and then the next method is add to do item async. So if you have a look, add to do item async and toggle to do item completion async, these two are the methods to be implemented. So add to do item is also easy, public and call this method and you have to give it an item, say to do item. Okay, because if you look at the signature over here, so it accepts a to do item, and both of these two methods accept a to do item. Okay, now rest of the method button.id. To make it explicit type of ID and distinct ID which is not repeated, so ToDoItems.count plus 1 is a way of doing it. It will give it a unique ID and then add it to the collection. Call that add method and pass the ToDoItem. Alright, and then now this part is corrected because this task is actually, it is not returning anything, so I don't need to actually return anything, so I will just use the await keyword. So await task dot completed task, so that it accepts. Alright, and there is another method that is public task toggle ToDoItem completion async. Alright, so let us write that one. It will complete all the implementation of all the three interface elements or interface members. So public async task So as I told you, it is using the isCompleted property of the ToDoItem class. So is ToDoItem.isCompleted is not ToDoItem. If it is not completed, it will be completed by sliding the switch. It will be shown completed. So ToDoItem.isCompleted is not ToDoItem.isCompleted. It's for toggling. And in again, await task dot completed task, not completed task. So that will complete all of the three implementations, right? And next is, now we have to register the service IT2 service and as to-do service. Okay, so I'll have to do it in the app class. Why app class? Because my program actually bootstraps the app class, and the app class is where we register because this is the entry point. Okay, so in the app.xaml.cs file, we already have these two lines, initialize component and main page is actually created as a new app shell. So after this initialize component, this will be var create builder, so how do we register? Builder dot services dot add scoped. I2do service, and an instance of I2do service is to-do service. So basically we are registering the to-do service class as scoped. So we could add services.add singleton also, or we could add add scoped or add transient or add singleton, but I have chosen to use add scoped. Why? Because because it is a .NET MAUI application, and MAUI applications are stateful application, and so the to-do service also maintains state or resources that should be scoped to a specific client request, or for example database connection. So in this case, add scoped is appropriate. So each client request would get its own instance of to-do service. Now next is, the next line is builder dot build, and that is equated to a variable app. Builder dot build, calling the build method on the builder, and then app dot services dot get service, hi to do service. So this ensures that this is followed by a pair of circular brackets, ensure that services can be resolved by get service. Okay, we shall now create a ViewModels folder, and I'll tell you shortly why we are going to create the ViewModel for this project. So ViewModels, and in which I will add a class you can call this class my ViewModel or anything, but I'll call it main ViewModel. Alright, make it public. So public class main ViewModel, and this will have a, I will now show you the dependency injection which I told briefly, and the utility of dependency injection in this entire project. Per private read-only variable I to do service, and call this underscore to do service. So this is suggested as to do service, so I'll put an underscore as a convention. Okay, and now then I will declare an observable collection of to do item type, which will actually be a property getter, and it will be assigned to a new observable collection. So observable collection is nothing but a list collection, it is IEnumerable type, which is observable. So I'll talk about that in a bit. So public observable collection on to do item, that's our only model class, to do item. So remember, I have already used this using statement to do list app dot models and using to do list app dot services. So you have to bring these two you can say files in our project, in our main ViewModel class. So public observable collection to do item, let's call this to do items, it's the getter, and this is assigned as a new observable collection of to do item. So a bit on observable collections. Now this observable collection, on it's a generic collection class. So with the to do item in this present case, it could be substituted with a T, generic T type, generic collection class, which is provided by the .NET framework and specifically in the system.collections.object model, this namespace. And in the context of a view model in an model view model architecture which we are following in .NET MAUI, this observable collection T, or here it is T is substituted by to-do item, is often used to present or represent a collection of items that the view should display or interact with. Now, observable collection is a dynamic data collection that provides notifications when items get added, removed, or when the whole list is refreshed. Now, it implements the iNotify collection change interface, which allows it to notify subscribers such as UI controls when the contents change. Okay. Now, in the view model, an observable collection of to-do item is typically used to store and manage the list of to-do items that the view needs to display. The view model exposes this collection as a property, allowing the view to bind to it. As to-do items are added, removed, or modified, observable collection automatically notifies the view of these changes, ensuring, mark these words, observable collection automatically notifies the view of these changes, ensuring that the UI stays synchronized with the underlying data. Now, overall, the observable collection on T, generic T type, in the view model provides a convenient and efficient way to manage the collections of items in MVVM applications, ensuring that changes to the data are reflected in the UI in real time. Okay, now we'll come back to the use, why we are using a main view model or a view model folder within which the MVVM architecture. So what will be the use? So we'll come back to that after completing the code for the main view model class. So let's keep on writing. Now public constructor here, main view model. Now here I will inject this to do service. Okay, and this is again an example of our dependency injection. So we are injecting the dependency without actually creating the object, so that the to do service class can be used. Okay, so here underscore to do service is assigned the to do service that is injected. Okay, it's a very common practice. So again, this dependency injection, I'll repeat, it's a design pattern for those who haven't heard about dependency injection before. And this design pattern, it allows us to decouple our application's components, making it easier to manage dependencies and promote code reuse. So in our TodoList app, we have now used the dependency injection to inject services like iTodo service, which we have I have told you in the beginning, and we'll later register the service in our app.xaml class later, that I will show. And when I said that I will register this service in the app class, mainly because if you look into the MAUI program, it bootstraps the application with the app class. So it uses builder.useMauiApp and passes app. So app is that class which actually registers our services, like in the ASP.NET Core that we are used to, we are using that in the program file. So here in the MAUI program, it is calling the app, and app is the place where we'll register service, but that will come later. Alright, so let's keep on doing what we are doing. So after building that constructor, we'll write the methods one by one. load to do items async. Dot get to do items async. So here you can see that this is a wrapper around the service class. So we are not calling the service class, which is actually not used for the presentation. However, the main view model or view model classes are used for presentation, and this is our to do service class is actually interacting with the data and manipulating data. So this will lend a layer of abstraction or decoupling also by using the view model. Okay, things will get even clearer as we go on. So load to do item async. Now there is a for each loop. Tab. So for each var item in to do items, because this is type is list of to do items. So this is a list collection. This collection is a list of to do items. Okay. So for each var item in to do item, so to do item dot this is the to do items, this observable collection. So we'll add to the observable collection by calling the add method and passing item to do items dot add item. Next there will be another method and it's passing the title. So add to do item async. So asynchronously we'll add a to do item, and title is the only thing that we could add because there is another field is just boolean, which is it's completed. Okay, and so far new to do item, and we'll put the title because title is passed. So title equals the passed in title to the as a parameter to this method, and then indent it a bit, and then await on to do service dot this time add to do item async and pass this new to do item. So we'll call in the service classes add to do item async and then pass this new to do item. This one, and then to do items dot add item, new to do item, rather this new to do item. So we awaited the call to the to do service methods, the to do service methods add to do item, and added it asynchronously by passing this new to do item, and then to the to do items, this observable collection, I add the new to do item. new to do item, and then end here. Finally, we'll have another method. So this is a small one, single liner. So toggle to do item completion async, it will just activate the toggle switch which you are going to make. So it will await. So to do service objects toggle to do item completion async, similar name, and pass this to do item. Now here it takes actually a parameter which is to do item. Okay, it needs a to do item type to be passed. Okay, so now everything is fine. So save it. Now I have written this class. Now this is completed. Now let's talk about why I need this class or MVVM. What is the significance of basically this MVVM architecture? Now the thing, after having studied this code, you will see that it addresses the separation of concerns, so that the view model which separates the concerns of data presentation and business logic from the UI. Now this separation, this will be more, it will make more sense when I actually complete the project by creating the MainPage.xaml, completing this and writing the code behind file. Okay, so this separation, anyway, let's continue. This separation makes the code base cleaner, easier to understand and maintainable. Now it adheres to the model view model architectural pattern which promotes modularity and testability. And also view model classes help in decoupling the UI from underlying data and services. This decoupling improves code maintainability and flexibility. Now changes to the UI or underlying data structure don't directly impact the view model and vice versa. It enables better code reusability and scalability. And of course I have spoken about the testability. So view model classes are easier to test compared to code behind files. Since view model classes contain the application logic, including interaction with services and data manipulation, unit testing becomes straightforward. Now you can write automated tests to verify the behavior of view model methods independently of the UI. And also in data binding, view model acts as a bridge between the view and the model, that is the data. So here the only model is to do item. So this to do item class is used in the to do service. Okay. So basically we are using the model class so it acts as a bridge between the view and the model, and it exposes properties and commands that the view can bind to, enabling seamless communication between the two layers. Okay, the two layers of the view and the data actual. Okay, the data binding simplifies UI development and eliminates the need for manual synchronization between UI elements and data sources. And it also adheres to the single responsibility principle. By using view model, you adhere to the single responsibility principle, which states that a class should have only one reason to change. And the view model classes encapsulate the logic related to presenting data to the UI, while services handle data retrieval and manipulation. So services handle data retrieval and manipulation. So this separation of responsibilities leads to cleaner and more maintainable code. So here, although it may seem like adding an extra layer of abstraction, Using ViewModel classes bring several benefits such as separation of concerns, testability, decoupling, data binding, and adherence to design principles. These benefits contribute to the overall quality and maintainability of the application, especially as it grows in complexity. Right. Before we move forward, let's run this application by actually removing everything from the MainPage.xaml file. Okay, so we'll remove everything. We'll keep this vertical stack layout, image, label, everything we'll remove. And just keep the vertical stack layout. And see what it shows. So after removing everything from the markup page in the C# code, these are no more valid. So I will get rid of this method also. Save it. Click on this Windows. So this is something wrong here. Oh, there is another bracket, closing bracket has to be there. So click on Windows machine. So now the page has come up with a blank page, home page, because there is no markup there. There is no images or text. Okay, so we'll close the application again. Now the main page, when the project is created, lies on the root of the project, MAUI project. So it's a good practice to create a views folder and keep all your XAML page, even the main page.xaml and any other pages that you might build within the views folder. So let us create a views folder. Okay. Yep. So MainPage.xaml. Okay. So now let's write the markup for the MainPage.xaml. Now here it is TodoList app.mainpage.views.mainpage because it comes from the views folder. Next class, TodoList app.view.mainpage. Rather views. The folder name is views. Alright, now that blue squiggly line is gone, so I've got that scroll view. Within that, a vertical. I'll get rid of the scroll view because there is no more scroll view required. We'll be creating a list view. So for that, I need a stack layout. Now here you can see the content page is the topmost table of a XAML markup. XAML markup has got a page, and within page there is a layout, and within layout there are views. Okay, and even a layout is also a view, which I will show you. So we have got a stack layout, and there is a padding to make it cleaner. There is a padding I put, and stack layout. Now within that stack layout, what is the stack layout? If you click on the go to definition, so it derives from the stack base. Okay, it is depending on stack base. And what is the stack base class? So if you peep into the definition, it is a layout. So that's also a layout. So within page it's a layout basically. Okay, so it's a layout. So within page layout, and then within layout there will be whatever UI elements are they will be actually views. Okay, like the label, the list view, they are all views. Okay, and you can see even a layout is also a view. Okay, so if you go back, so stack base class, it implements layout. Okay, and layout, we have shown you that layout is also a view, right? And so stack layout is implementing stack base, so it's all view. So within page it's layout, and within layout it is view. However, layout itself is a view. All right, that's the hierarchy of page structure in MAUI. But one page or one content page can only have one layout, and within that layout there can be many views and even more layouts. So we'll see there is a label, text attribute, so we'll make the text a to-do list with a font size it's absolute 24, and you can give it any number. Horizontal options is center, and I'll put a margin. So left, right, top, bottom, margin. Okay, you can play with the margin, so you can easily find out which of these numbers represent margin from which side. Okay, right. Now next comes our list view. That's what I have told you, that we will display to-do items in a list view. Okay. Now this is the way it is in a XAML file. The names are written with a X attribute X, which is name to-do list view. Is the like here it is X class to-do list app dot views dot main page. Let's complete the list view, and then I will explain each and everything. All right, so list view X colon name equals to-do list view. So X colon name, that means X is a prefix, so it refers to as an attribute in an XAML file. Okay, so here the name attribute is to-do list view with a margin, and here item source is binding to-do item. It is bound to to-do items. So it assigns a unique identifier name to the list view control, allowing it to be referenced in code behind. And this is the margin, and this is the item source binding to-do items. It binds the items source property of the list view. This is the list view property, item source. It binds the item source property of the list view to a collection of to-do items. The to-do items property is expected to be available in the data context typically provided by the ViewModel. And this is the item template. This is the writing the template for each of the items. Okay, it defines the template used to display each item in the list view. And data templates defines the template used to display each item in the list view. Okay, And view cell, it represents a cell in the list view which defines the layout for each item. And then stack layout with the padding of 10, background color of, this is the background color, and margin, this is quite obvious. And then label text, here it is bound to title, property of the to do items, okay, with a font size of 18. Okay, it binds the text property of the label to the title property of the data item. And switch is toggled, binding is completed, toggled on to do item toggled. It binds the toggled property of the switch to the is completed property of the data item. And when the toggle switch is toggled, it triggers the on to do items toggled event handler, which we are going to write. Next, we'll add the entry for adding a new to do item and a button UI. So these are two views, so I'll just paste the code over here. Right, and do the indenting, and so it's a entry for adding a new to do item, and its name is, as I just told you, explained you about this X. It is an attribute, and it actually gives a new name, a new identity to this name property, which is new to do entry, and it has got a placeholder, enter new task. Okay, so you can place some text. It's just like a text box here. So, and the button text is add to do item, that is the what is engraved on the button, and on click it will create it will actually, there's an event, it is wired to this method. So if we click on right click and go to definition on add to do click, so I have to write some code to hook up this event, wire up this event. Alright, now that will come in the MainPage.xaml.cs, so which I just opened. So once again go to definition, so I have to now write this main page, which is actually derived from the content page, which is a content page in fact. Okay, so here, now that our view model is ready, so it is create a read-only property of type main view model and call it underscore view model. And in this public constructor, initialize component was already there, and then I will use this view model variable that I have just created, and I'll create an instance of main view model class and pass a new instance of to do service. And my binding context is this view model. So what is this binding context? So this binding context is it is coming in terms of the data binding. So I am binding the context of this main page with the view model. By setting the binding context property to an instance of a view model, in this case the main view model, We are essentially establishing a connection between the view and the view model. A view is the UI. This connection enables data binding, allowing properties of the view model to be bound to UI elements in the view. And it also enables two-way communication. Once the binding context is set, any changes made to the properties of the view model will automatically reflect in the UI and vice versa. This enables two-way communication between the view and the view model. For example, if a property in the view model changes, the corresponding UI element bound to that property will update to reflect its new value. And the context for binding expression, when we define binding expression in XML, like binding to some property, the binding context specifies the context in which those expressions are evaluated. In other words, it tells the view where to look for properties referenced in the binding expression. So in summary, setting the binding context to the main view model in the main page constructor establishes the view model as the data source for the main page. It enables data binding between the UI and the view model, allowing for seamless synchronization of data between the two components. So next, let's complete these two, this method first. On add to do clicked. So new to do entry dot text. So I am putting whatever the text is there in the new to do entry, that is the placeholder or the entry. If you look at MainPage.xaml, so new to do entry. So entry is nothing but a free text, just like a text box in Windows application. So getting back here, now there's an if statement. If it is not a null, or if it is not a white space or null, this new to do title, if there is something in there, then do what? Await on this view model dot add to do items async. That was a method within the view model, add to do item async, and then pass this new to do title. All right, and then make it empty. New to do entry dot text. So you just reset it. Empty. And that's it. And then there is the last one, which is on to do item toggled. Now just to save time in typing, and this is this one. So this is on to do item toggled. You send the object sender and toggled event args e. So if sender is switch type, toggle switch, if it is toggle switch, and also toggle switch dot binding context is to do item. Okay, you can write like this. Then await on the view model dot toggle to do item complete async to do item. Pass that to do item, because that is also a method within the view model. So if you look into definition quickly, so this is one. Okay, and this is calling the I2do service, and then passing and calling the toggle to do item completion async and passing the to do item here. So it's now all done. Now when I ran this application, it comes up with one error: cannot resolve type CLR namespace : TodoList App dot main page. So TodoList App dot main page. So here actually this is TodoList App dot views, because the main page lies in the views folder. Okay, now it's gone. And now if we run the app once again. Now something I have missed on this page, MainPage.xaml.cs, that is actually there is another method called onAppearing, which is just you can as a developer customize the onAppearing, which is overridden in the derived class. But it says that when overridden in a derived class, it allows application developers to customize behavior immediately prior to the page becoming visible. Okay, so this is based on appearing, we are actually overriding, and then we are calling the load to two items async method to load it asynchronously. So if you go to the definition, and this is actually for each item in that to do items observable collection. Okay, this to do items to the to do items observable collection, you are adding this item. Okay, so and this to do items comes from here. Okay, so you're getting it asynchronously from the to do service. So if you now after doing this last change and coming back to our original file, which is this one on appearing, and now if you run the application, so now when I run this application after cleaning and rebuilding and finally clicking, because it came up with some silly error, I don't know whether it is a bug in .NET MAUI even in the latest version, but it came up with this result. So if I add a to do item task 4, it will be sitting over there, and you can just hit the slider to put it on position. So that is the end of my lecture on how to create a .NET MAUI TodoList application, and in the process I have shown you the data binding and dependency injection in full detail. Hope you have added some value to your knowledge, and if you have liked this video, please subscribe to the channel and please hit the bell icon notification and share it with your friends. Thank you.